Okay, we're going to start our bundle on logarithms, and we're going to start with just talking about some exponential functions and the inverse. So if you were asked to find the inverse of an exponential equation, y equals b to the x, your first step would be to exchange the x for the y. Your next step would then be to solve for y. But this time it would be a little bit difficult because y is an exponent. So we actually need a new function that's going to help us to solve that, and that's called a logarithm. A logarithmic function is the inverse of the original exponential function. This means that a logarithmic function is simply an exponential function in an alternate form. And it's really important that you're able to convert back and forth between logarithms and exponential functions. We just wrote x is equal to b to the y in logarithmic form, or we can write it, in logarithmic form as y equals log base b of x. And something that helps me to remember how to go back and forth, if I have y equals log base b of x, I know that b to the y power is equal to x. Remember, in a logarithm, what it's equal to is going to be your exponent. So we can write that as b to the y power is equal to x. So we're going to work through several examples here, just writing first in logarithmic form. So here we have our base, and remember how I said it. I said log base 2, and what it's equal to is 64. Our log is going to be equal to the exponent. Let's try again. Here we have the base, so log base 4, that's a subscript, so it's a small 4, of the answer 16 is equal to the exponent. On C, we have log, the base here is 5, the answer is 125, and that's going to be equal to the exponent. Here we have log, my base is 36, of 6 is equal to the exponent. And here log of the base of d is equal to the exponent. All right, now let's try working somewhere we're actually writing from log to exponential form. So remember, the base 4 of the exponent is equal to our log. Base of 5 squared equals 25. Here we don't have a base that's written, and when it's not, we're going to assume that's a base of 10. This is actually called a common logarithm. So my base here is 10. It's to the third power. Our exponent is our answer in a log, and that's equal to 1,000. On D, our base is 8. Our exponent is 1/3. And that's equal to 2. And our last example on part 1, log base x of y is equal to z. Our base to the exponent is equal to y.